Okay, so in the last video I did a basic explanation about what data structures in general are. If you didn't watch the last video, just basically a data structure is some type of structure that holds data. It's pretty intuitive. So now I'm going to talk about the first basic type of data structure, which is called an array. An array, it's primitive, so you don't actually have to have an array class or anything to be able to use it. You don't make like you learn in Java how to create a new object via something like can I type? You do something like new foo, which you learned in your Java class, that would create a new object of class foo using the foo's constructor. So to create an array, we don't do that. All we have to do is the basic syntax. Let's say I'm making an array of integer objects. I would do something like integer my r equals new. Oh, so I guess it is kind of, yeah, I guess, so, but you're not actually using like a constructor, you're using this syntax. So I'll put a question mark here. So let's dive down into what this means. So when you create an array, it's basically a collection of whatever object type that you want to put in it, and it has a set size that you have to define from the beginning. So to create it, you say I'm making an array, which is these brackets, of type integer. It's named myR, and then this is the initialization, and then let's make it of size question mark. So question mark could be like, I'll say 5 for now. So what that would do is somewhere in memory it would create a new collection. This memory is already allocated. Some 5 slots somewhere. This would be our array in memory. And then it starts as, if it's an object, it would be null by default for all of them. And then if it's a primitive data type, it'll be 0 or whatever the 0 equivalent would be for that data type. So basically an array, as I mentioned, there's some key components of it that, you know, they kind of define whether or not you want to use them. The first key component is the memory is pre-allocated. So what does this mean? It means that the moment I create my new integer array called myR, it allocates whatever size an integer object is, it allocates 5 times that right here. Or I guess it starts as null, so not necessarily, but yeah, so in general memory is pre-allocated, so it could be very wasteful. The second thing, which, you know, kind of deals with this one, so if the memory is pre-allocated, that means that the size is preset. This tends to be the most significant part of like the downfall, or one of the most. That size is preset. You saw that, I'll put my semicolon here. So you saw that when we create our new array, we define the size right here. From the moment that array is created until the moment your program finishes, that array cannot change size. We could create a new array and then point this pointer to that new one, but this specific array will have to stay at 5 elements long. It can never expand. Which, I mean, it's kind of assumed based on this memory is pre-allocated. If it were able to expand, how would we be able to pre-allocate memory? We wouldn't be able to. So now that these two, you probably see them as cons. Then the third thing, which is the main benefit of it, is random access. So what does that mean? So this ties into thing 1 again. Point 1, that memory is pre-allocated. Let's say in the memory, this is at memory location 1000. Let's say this is 1001. Let's say this is 1002, 1003, 1004. If I want to call on any given element, so if I want to see what my are the fourth element, so element at index 3, because we know it goes from 0 to n minus 1, but so I want to find the fourth element, which is at index 3. This pointer already knows, okay, my first element is at index 1000, and all the elements after that are in a straight line from there. So the index 3, without even having to really look for it, it knows automatically that, let me look at memory point 1000 plus, let's see, so the first one's 1000, second one 1001, so it would do element location 1000 plus 3 would be element location, like memory location 1003, let's say. So without actually having to do any searching or anything, it knows that it would jump right here. So no matter what we're doing, we can access our elements instantly. So that's basically the function of arrays. I'm not really going to talk about how you initialize them and their usage, how to use them, because that should have already been done in a previous Java programming class. This is mainly just to discuss about the memory structure itself. I mean the data structure itself. So these three things, this third one is a benefit. These two, the first two, are cons, definitely. But so this memory is pre-allocated. We can't really bypass that con. But this size is preset is something that we can not really bypass completely, but we kind of hack through it in a way. And that, I'll make another, or let me use a different color. In my next video, I'll be talking about that. It's a data so let me, to be able to avoid this preset size thing, we'll be using what's called an array list, which I'll talk about in the next video. Essentially, it's a data structure that uses an array as a backing data structure. So it's some object, as you can tell by the capital letter. It's some class that one of its instance variables would be some array, but then it does other stuff. So yeah, just before I finish off this video, in the last video I mentioned four main methods that, or like four methods that pretty much any data structure has, which would be add, remove, this looks ugly, I'll just say them. So I mentioned any data structure in general that you write from scratch would have four methods that it would pretty much always have. They're add, remove, size, and contains. Where add adds an element, remove removes an element, size returns the total size, like how many elements you have, and contains returns true if the element is in it or false if the element's not in it. So with an array, there's no size. What we can find is the length, but we can't really find the size. So the length is the total capacity of our array. So for this one that I created right here, it would have a length of 5, because we can only add 5 elements total. So if I did my r dot length, because remember it's an instance variable in this array, it would return 5 because that's the overall capacity, that's the length of this array. And then add and remove we do directly, which you learned in a Java class. We just could say something like my r3 equals some integer. And then remove, so to remove an element, we just kind of overwrite it. Pretty much there's not really removing elements in an array. We would just overwrite it with something else, or we could set it equal to null. And then contains, there is no method. So the only way to be able to find something in here would be to manually search for it using a for loop. So yeah, we'll learn about how to bypass some of those problems with an array list, which I'll talk about in the next video.